I think the problem was about a boat coasting to rest, where the acceleration, or dv dt, and of course that is the acceleration, is negative in the sense that, you know, if v is in the positive direction, your acceleration will be in the negative direction, because a boat coasting to rest slows down. It experiences a force opposite its direction of motion, and that's the drag force of the water. That's just a little enrichment. You don't have to understand drag forces at this point. But this is actually a pretty simple problem. It doesn't look like it ought to be, but it is. Okay, so if we write dv dt equals negative kv squared, which is what is given for the problem, can we find a function for v? Well, sure, we just integrate both sides of this. Well, first we rearrange this as dv over v squared equals negative k times dt. Very simple arrangement. And, you know, can you really do that with infinitesimal quantity with dt's and dv's? Well, turns out you can. And physicists don't worry about the details, the mathematical details of justifying it. They can be filled in. It's justified, okay? And differential equations, of course, you'll see how they're justified. Right now, all we're doing is we're taking this equation, putting it into this form, integrating it. Antiderivative of dv over v squared, well, that's v to the negative 2. The antiderivative is negative 1 v to the negative 1, or negative 1 over v. And you can verify that very easily. And you really, your calculus has to be good enough to do this stuff. You know, you don't have to do a lot of trigonometric substitutions and derivatives of arc tangents and so forth, at least not first semester. So the calculus is pretty simple. So we get negative 1 over v, and of course you have your integration constant. And on this side you got negative kt. I didn't write the integration constant over here because whatever integration constant is here can be subtracted from both sides, and you still get an integration constant over here. Since both integration constants are unspecified and arbitrary, when you subtract them, it's still arbitrary and unspecified. So you get, and I was careless, again, I lost my negative sign. 1 over v will be negative kt plus c, so that v is going to be 1 over negative kt plus c. And then to get your x function, your position function, you integrate your velocity function. So x is the integral of v dt, and that's going to be negative 1 over k times the natural log of kt plus c, of negative kt plus c. And you can take the derivative of this. What are you going to get? You're going to get a negative k over kt plus c. Then multiply it by negative 1 over k, you just get what you started with, 1 over negative kt plus c. And the problem that's involved with, I actually have that in the assignment. There's the calculus of it. You see the calculus of it is pretty easy. And in this course, usually the calculus, if you're up on your calculus, is the easy part of a lot of problems. So this is really pretty easy, pretty straightforward. Now you get to put the information in the given problem into this form and do some algebra, and then interpret what you got.